and say which are rational numbers. Okay, so we have question 7, so this is worksheet 1. Okay. Exercise 1. So we have number 7 there. Right, so we are given square root of 11. Is square root of 11 a rational or an irrational number? It's irrational. So you can't convert it to a common fraction of the form a over b. Okay? So this one here, we'll just say that's irrational. Okay, it's not possible for you to convert it to a common fraction. And the next one is number 8. Okay, so number 8, you are given 2,1 carrying and 7 carrying. Right? Is that an irrational number or is it a rational number? Rational. It's rational. Now, if it's rational, can we convert it to a common fraction? Okay, so it can be converted. That's why you need the last example that I did on Wednesday for you to convert it to a common fraction. Now, the number of digits that are recurring determines the multiple of 10 that you are supposed to use to convert it to a common fraction. So we have got 2 digits, okay, that are carrying the 1 and the 7. So the first step is to say, let x be equal to 2,17. Then you say dot dot up to infinity. That will be your equation 1. Okay, no calculator. Okay, I'm not using a calculator because I'm a mini calculator. Okay, as I told you last time, you are also the best calculator. If you want to make your brain sharp, you must use it. So the next thing now, we are going to multiply this equation on both sides by 100 to convert it to, for us to be able to convert to a common fraction. So the next step will be, you can say therefore, if you want, it's 100x is going to be equal to 217, 17. Now, it's very important for you to know that in the first equation, there is the one after that 7. And after there is the one after this 7, and there's another 7, and then it carries on. So when you multiply by 100, it means that the 2 digits after this 1 and that 7 are going to move to the left. That's why we end up having this 17. Then you must put dot dot there to indicate that there are other digits, that is 1s and 7s after. Okay? And make sure that the number of decimal places is the same in the first equation and the second equation. Because remember, when you are doing this calculation, you are not supposed to use a calculator. Okay? Then you subtract equation 1 from what? Equation 2. So by subtracting equation 1 from equation 2, okay, we'll end up having 99x is equal to 215. Okay, no calculator. Okay, then you divide both sides by 99, so your x is going to be 215 over 99. Now, 215 over 99 is an improper fraction. So if you want, you can convert it to a mixed number. Okay, you can convert it to a mixed number. If you do that, what do you get? It will be 2 and what? 2 and 17 over 99. Okay, again, you don't need a calculator to convert 215 over 99 to 2 and 17 over 9. You should know that 99 times 99, that will give you what? 198. Subtract 198 from 215, you get 17. That 17 will be on your numerator and the 99 will be your denominator. Then you've got your whole number there. That's a 2. Okay? No calculator used. Right? So mark your work. If you made a mistake somewhere, then you correct yourself. Okay? Any question? Right, let's move on to the next question. The next question is question 9. Question 9. Now question 9, is that a rational or an irrational number? It's what? Yeah. Right, how many of you can say, Mr. Chiponda, that decimal there is irrational? Raise your hand. Just be honest, just raise your hand. Alright, so it means if your hand is down, it means you're saying it's rational. Right? Now, this decimal 0.376534, because there are no dots after the 4. Okay, there are no dots after the 4, which means it's a terminating decimal. All terminating decimals are rational numbers. All terminating decimals are rational numbers, which means they can be written as common fractions. Okay? It's not recurring, yes, but it is terminating, so it becomes a rational number. Okay? So, how many digits are there after the comma? There are 6. Okay, so which multiple of 10 are you supposed to use to convert it to a common fraction? So this is rational. So we can just write that equal to 376,534. You said 1 what? 1 million, am I right? Yes. Then you divide that by 1 million. Now, because the unit digit is a 4, okay, it means we can simplify it. So if you simplify that whole fraction, what would you get? You can use your calculator if you want. It will be 188,267 over 500,000. Okay. Alright, so that's number 9. Then number 10. Number 10. Then number 10 you've got the square root of negative 25. The square root of negative 25. Now, is that rational or irrational? Rational. Okay. From now on, you must know that it's neither irrational or rational. It's not a real number. Okay? It's a non-real number. Okay? It's a non-real number. So, we just write that the square root of minus 25 is non-real. Okay? It's non-real. It's not rational or irrational. It's non-real. It's impossible, according to your curriculum, to find the square root of minus 25. Okay? Okay, in terms of whether it's a real number or it's not, it would be better to say it's non-real. Of course, it's true that it's undefined. It is true, but based on the number system, right, it is a non-real number. Okay? Right, any question for Kero? Alright, any question? Right, let's go to the next exercise. Exercise 2. How many questions did I give you for exercise 2? 9 to 12. Huh? So exercise 2, start with question 9. It says, state whether the following are rational or irrational. So we have square root of 1. So this is minus square root of 1. Is that rational or irrational? It's rational because the square root of 1 is a 1. So minus 1 is an integer, which means it's rational. So this one here is rational. Okay? Then number 10, you have the square root of 2 over 2. Is that rational or irrational? It's irrational. Why is it irrational? Okay, it's mainly because the numerator is not an integer. Okay, the numerator is not an integer, so that's irrational. Okay, then number 11, that's the square root of 9 over 7. Is that rational or irrational? It's rational because the square root of 9 is an integer, and the denominator is already an integer, so that's rational. And then number 12, the square root of 5 all squared. That's rational. The square root of 5 all squared is equal to 5. So this is rational. Sorry? Number 11. 9 is a perfect square. What's the square root of 9? It's a 3. So this is the same as 3 over 7. It's a common fraction. The numerator is an integer, the denominator is an integer, so it's a rational number. Remember, all common fractions are rational numbers. All common fractions are rational numbers. Okay. So let's move on quickly to the next one. Alright, it's not supposed to be exercise 5 there, it's a typing error, it's supposed to be exercise 3. Right, but we'll work with it as it is. Supposed to be exercise 3. Okay. Which question did I ask you to do there? I think I gave you 3 questions. 1.3 and 1.5. Okay. 1.3, 1.4, and 1.5. Right, let's start with 1.3. So that would be exercise 5 based on the worksheet. So that's 0.45 recurring. Alright. Now, here you need to be very careful. It is the 5 which is recurring. The 4 is not recurring. Okay, it's the 5 that's recurring. So this question here is slightly complex, but the basic concept of converting a recurring decimal to a common fraction still remains the same. We have one digit that's recurring, so we multiply it by 10. Okay, so we'll say let x be equal to 0.45. Then I'll put dot there. That's the first equation. Then we'll multiply equation 1 by 10. If you do that, you get 10x equal to, now you end up getting 4.55. Then dot, that's equation 2. Okay? Then, when you do the subtraction, that is, you subtract equation 1 from equation 2, you get 9x is equal to 4.10. Alright? Did you get that? Okay. Can you please raise your hand if you've got that equation that I just wrote? 9x equal to 4.10. Okay. If you multiply by 100, you might complicate the question. Right? The best multiple of 10 that you can use is 10 itself. Okay. Why 10? Because there's one digit that's recurring. The 4 is not recurring. The 4 is not recurring. It's only the 5. Okay? Then we can convert this. Yeah, you see, the number of digits that are recurring determines the multiple of 10 that you're supposed to use. If there's one digit that's recurring, use 10. If there are 2 digits that are recurring, use 100. If there are 3, use 1,000, and so on. Okay? Right, so from here, you get 9x, right? Now, this 4.10 is now a terminating decimal, so we can convert it to a common fraction. It is the same as 4 over 10. So 4 and 1 over 10. Like that. I can write it like that. Then I'm going to convert the mixed number to an improper fraction to make it easier to solve the equation that is to solve for x. Okay? So we'll get 9x is equal to 41 over 10. Now, once you get here, you're in grade 10, you started doing equations in grade 8. So this becomes like a grade 8 or 9 equation, which everyone in this class should be able to solve without any problems. Okay? So let me change the color to just carry on the other side. Right? You just cross multiply. Obviously, the denominator there is going to be a 1. So you end up getting 90x is equal to 41. So your x is going to be 41 over 90. Okay? Now, if you want, you can test, okay, whether the answer that I got there is correct by using your calculator. You can use the calculator to verify the answer. So in your calculator, just put 41 over 90, press equal, and see what your calculator gives you. It should give you 0.45 recurring. Yes?
I use the method of 100x and I still got
Yeah, it's fine. It will give you an answer even if you use 1,000, but it makes it slightly more complex. Yeah, but you still get the same result. Alright, so if you use 100, it's fine. Okay? If you are in a test, you get your full marks. If you use 1,000, you show all you're working out, you still get your full marks. But you must get to x equal to 41 over 90. Okay. Right. Let me move a little bit quickly. Yeah. Right. From now on, don't stress if you probably are behind in terms of writing, because I'll create a PDF for it and I'll send it on you. You can always catch up later because we don't have too much time. All right. The next one, it's 1.4. Right. There are two 1.4s. The last one, that should be 1.6. So I'm going to do 1.4, the first one. That is 0.63 recurring. Okay? So we have 0.63 recurring. Right? By now, you should all know what to do here. It's simple. Right? So we say let x be equal to 0.63 dot, that's our equation 1. Since there are two digits that are recurring, we multiply by 100, and you get 100x equal to 63.63. That's the second equation. And then you subtract equation 1 from equation 2, you get 99x equal to 63. So your x is going to be 63 over 99. Okay? Now, can you simplify further 63 over 99? Yes. So that becomes x equal to 21 over what? 33. Sorry, what? Okay, wait, I think I made a mistake. Okay, 3 into 63, that's 21, am I right? Huh? Okay. What's the common factor of 63 and 99? 9. Okay, I use the smaller one. Okay, 9, so that gives you 7 over 11. Okay. So it means if you write it as 21 over 33, you still have to simplify it further to 7 over 11. So this is the final answer, which is simplified. If you have 21 over 33, it's correct, but it's not simplified. Okay, so you have to simplify them. All right. That's it. Then the last one. Now the last one, it's slightly more complex as compared to the others. So you have 0.1 recurring, 3 and then 5 recurring. So here you've got two digits that are recurring. Okay, but between them there is a digit which is not recurring. Okay, so let's try to multiply by 100. Okay, You might have used 1,000, it should get you to the same result, but it may be a little bit more complex. So if I use here, if I use say 100, okay, I'll say let x be equal to 0.135, okay, like that. Then I'll multiply by 100. So if I do that, I'll get 13.5. Now, since we have got, remember, we have got two digits that are recurring, that is the 1 and the 5. So this becomes 515. Do you agree with me on that? Because of the recurrence, okay, the 3 is not recurring. So it means after this 5 here, there is a 1, then a 5. So when I multiply the first equation by 100, the 1 and the 3 move to the left-hand side of the comma. This 5 takes the position of the 1. Then the 1 and the 5 that are there will move to the left. Okay? Then you need to do a subtraction. So this gives you 99x is equal to, now if you do a subtraction here, what do you get? 13, comma what? It's 13, comma what? What is 515 minus 135? Can you drop your body calculator? Tell me the answer. What is 515? Yes? It's what? 13.38. So this becomes 380 there. But we can just write the 13.38. Okay? But 515 minus 135 gives you 380. But because the 380 is after the comma, we can write it as 38. Then we exclude we don't have to write the same. Then from here we convert that to a common fraction, so that becomes 13 and 38 over 100. Now it's going to become a little bit large. When you simplify more, you get 1,300 plus that, so you get 99x equal to 1338 over 100. Okay? Now you have to show all these steps, right? Then from there we cross multiply, so you get 9,900 is equal to 1338, and that's x. So your x will be 1338 over 9,900. Right? Can you use a calculator to simplify that? It's going to be equal to what? 223 over 1,650. Okay. Did you all get that? X equal to 223 divided by 1,650. How many of you got that answer?
So I think in the textbook it says that it's 2, 1, 2. So it's the 2 dots on 2 and 2. Okay, so this text says 2, 3,
Alright. Okay.
That's where we can.
Alright. Can I just tell you something? A textbook, okay, is not 100% perfect. Okay? It is close to 100. I have to agree on that. Because the people who write the books, they are specialists. But mistakes can happen. Okay? Like here. There is a mistake here because in your textbook, it is only the 2 and the 3 that are recurring. The 1 is not recurring. Okay? The 1 is not recurring. Okay? So after that 3 there must be 2, then a 3, and then cancel. Right? Can you try to use a calculator? If you use a calculator for this, you get back here. Just check. Huh? Correct. Just test with your calculator whether this common fraction gives you that. Whenever you are doing this type of questions, you can check if your answer is correct. Okay? You can check if your answer is correct by using your calculator. Alright, I think I'm done here. Any